Welcome, dear students, on the chemistry class of 12th January 2021. Uh, Let us revise what we have studied into the previous periods. We have studied about the packing efficiency, my dear students. And then we have studied about the voids. So in the last period, we have studied about the packing efficiency for hexagonal close packing. And we found that it is approximately 74 percentage. Even in your face-centered cubic close packing, that is even very similar to the 74%. Then in your body-centered, it is approximately 68%. Can you tell me about the primitive? What is the percentage for primitive? Any of you, please? Can any of you tell me the percentage of packing efficiency for primitive? I am waiting. I want the answers from you.
52.
Who said this? Can you please your name, please?
Dromel.
Once again, please.
Dromel.
Drumil, thank you. It's a 52% approximately. So now we can even calculate the voids. Void we can calculate as 100 minus packing efficiency. So my dear students, for this hexagonal and face centered, we can say 26%. For this we can write 32%. For body centered cubic close packing, and for primitive we can write 48% of the voids. So these two are the most efficient way of close packing. At the same time, my dear students, we can even find out the relation between A and R. What is the relationship between A and R? So see, for example, if you think of the primitive unit cell, you can write this relationship as A is equal to 2R. Can you find out for the others? Can you tell me for body centered, for face centered, and for hexagonal close packing? I'm waiting, my dear students, if you can tell me. I just need this relationship between the body centered cubic close packing, face centered cubic close packing, and hexagonal close packing. The relationship between A is equal A and R.
4R is equal to root 3A.
It is for
Body center.
So we can write 4R is equal to root 3A, or we can write R is equal to root 3 by 4A, or we can write A is equal to 4 divided by root 3R. Now what's about this face-centered cubic cell? I think it is A is equal to 2 root 2R. Am I right?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
What's about the hexagonal close packing? We have just seen it. Yes, in the last period only, we have studied about this relationship, hexagonal close packing. If you can recall, what is the relationship between A and R? The relationship between A and R into the hexagonal close packing, my dear students. If you can tell me, the relationship between A and R for the hexagonal close packing, if you can tell me.
A under 2 upon 4.
Can you repeat, please? What is the relationship between A and R into the hexagonal close packing?
A into under root 2 upon 4 equals to R.
No, my dear students, even in case of the hexagonal close packing, we have A is equal to 2R only. Just check it out once again. My dear students, just check it out once again. Even in hexagonal close packing, we have this relationship between A and R is A is equal to 2R.
Yes, sir.
Do you get it? In hexagonal close packing, even we have this relationship A is equal to 2R. Now, A is equal to the sides of the cubic close packing. We can represent A is equal to side and R is equal to the radius of the sphere or radius of the particle. So A is equal to side of the unit cell and your R is equal to the radius of the particle which is present or which is arranged into the unit cell. My dear students, this table you should learn it well. Please learn it well. This table, it is very important. Please learn this well. It is very useful and especially when it comes to the solving various kinds of questions or various kinds of multiple choice questions into your competitive exams. These are going to be very useful data for you. So please keep it in mind and please learn it well. Now let's get back to the solution of the problem that we have started solving in the last period. Let me read the question for you. If the radius of the octahedral void is small r, you can see this is the void that we have, and the radius of this void is small r. Small r and radius of the atom in the packing is capital R. Derive the relationship between small r and capital R. So here we want to derive the relationship between the small r and the capital R. Let us understand it, though we have discussed it in the last period. Let me discuss it with you once again. Please pay attention, my dear students. Now you can see that if we have the face-centered cubic cell, then we have the face-centered cubic cell in this manner. You can see it easily here that we have the face-centered cubic cell with us. Now in this face-centered cubic cell, we have particle here 1 at the different faces. So 1, 2, 3, 4, 5 and 6. These are the particles present at the faces. Now with these particles we can have, my dear students, the void produced over here. So this is the void which I am showing you with the help of the red color. You can see this is how the void is being produced, or we can represent it. This is the octahedral void that we have here. This is your octahedral void. Octahedral void. So you can see that you can have a void over here. This void, my dear students, which is an octahedral void, have these particles which are present around it or surrounding this octahedral void. So we have this octahedral void here. Here we have the octahedral void, my dear students, but there are various particles surrounding these octahedral voids in this manner. So 4 particles in the same plane, one is above and another one is under this. This is how you can understand the octahedral void, my dear students. So the same thing I have explained you here in this figure, that you have these 4 particles present in the same plane. Each particle has its radius, and this radius is represented with the capital R. So these all are the values which are capital R. These all are capital R. Now with this we have the void present over here. So I shall represent it with some other color. You can see this is the void that we have, my dear students. This void also has got some radius. So if you look into this radius, my dear students, this radius of this void, which touches all these four, is small r. So even this radius, the next one is also small r. This is even the distance which is small r. Then you already know this distance is your capital R, and this distance is even capital R, because it is the radius of our particle. So now you can easily understand that your distance AC, A to C, is capital R plus small r plus capital R. That is 2 capital R plus 2 small r. That is 2 into the bracket capital R plus small r. This is what it is, the distance AC. Now if you think the distance AD is equal to DC is equal to BC is equal to AB is equal to R plus R, that is your 2R. Please remember, these are the values that if we think of distance AC, then it is going to be 2 into R plus R. Or if you take any other distances like AB, BC, CD, AD, these all are going to be 2R. Now by knowing this, we can solve this problem, my dear students, very easily. So let us try to solve this problem for us. How can we solve this problem for us, my dear students? Let's have a look into it. So now, my dear students, you can understand this. So now if you think of a triangle ADC, we are thinking about this triangle, dear students, that this is your triangle ADC. This is ADC triangle we are talking about. Now I'm going to draw this triangle ADC for you here. This is your A, this is your D, this is your C. This is, first you have capital R, then you have small r, then again you have small r, and this is capital R. This is what it is going to be, capital R, this is capital R, and this angle is 90 degree. So according to the Pythagoras theorem, we can write AD square plus DC square is equal to AC square. So let us write this AD square plus DC square is equal to AC square and understand it well, my dear student. So according to the Pythagoras theorem, we can write AD square plus DC square is equal to AC square. Now we know that our AD is equal to 2R. You can see here the length of AD is equal to 2R. So we can put 2R for our AD. This is AD. This is the distance which is AD. And this distance is R plus R. So 2R. DC is also 2R, R plus R. And this AC is nothing but 2R plus R. So AC we can write 2R plus R whole square. So now, my dear students, 2R square gives us 4R square. 4R square, that gives us 2R plus 2R whole square. So we can have 8R square is equal to 2 into 2R plus R whole square. Therefore, if we take the square root both the sides, square root of 8R is equal to 2R plus 2 small r. Therefore, my dear students, this root 8 is equal to 2 multiplied by 2 multiplied by 2. That is square root of 2 square multiplied by 2. That is 2 square root of 2. So for 8 we can write 2 square root 2r is equal to 2 into 2r plus 2 small r. Now if we take this 2r left side, so we can write 2 root 2r minus 2r is equal to 2 small r. If we take this 2r which is present in both of them common, then we can take 2r common. So we will have root 2 minus 1, which is common, is equal to 2r. Now we know the value for root 2 is equal to 1.41. So, and we both the side we have 2. So 2 divided by 2 gives us 1. So r into 1.41 minus 1 is equal to small r. And thus, my dear students, 1.41 minus 1 is equal to 0.41. 0.41 capital R is equal to small r. Or we can even say that small r divided by capital R is equal to 0.41. So please understand it and solve such problems whenever you face such problems, my dear students. Now let's move and understand the next question. If you have any doubt, you can ask me. बच्चों अगर कुछ समझ में नहीं आया तो आप लोग मुझसे पूछ सकते हैं बिना झिझक। क्या सब कुछ समझ में आया है आपको?
Yes.
Yes, sir.
धन्यवाद बच्चों। चलिए let's move forward and understand the next. An element has a body-centered cubic closed packing. We have body-centered cubic closed packing. That is what we need to understand, my dear students. So let's move forward and understand. An element has a body-centered cubic closed packing BCC structure with a cell edge of 2.88 picometer. That means it gives you the value of A. The density of the element is 7.2. Now they have given you the density. For density, my dear students, we have derived one equation. If you can recall, do you remember what is the formula to calculate density?
N into M divided by 8.
The formula is Z into M divided by Na into A cube. That is what it was, the formula to calculate the density, and the value of density is given. How many atoms are present in 208 gram of element? So some grams they have given, and that is we need to find out how many atoms are present into it. That means we need to first find out the Z that is present into the 1 unit cell, and then on the basis of the molecular weight we can find out how many atoms are present in that particular gram. So for BCC, let us solve this problem. For BCC structure, number of atoms per unit cell is equal to 2. So Z is equal to 2, that is what we are well aware. A is equal to 288 picometer. Picometer means 10 to the power 12 meter. So we just multiply 288 into 10 to the power 12 meter. And if we want to write it into the centimeter, we will write 288 into 10 to the power minus 10 centimeter. Density is given as 7.2 gram per centimeter cube. And we know that our Avogadro number Na is equal to 6.022 into 10 to the power 23. Now, my dear students, density is equal to Z into M divided by Na into A cube. Therefore, this molecular weight M is equal to what we can write? Density multiplied by Na multiplied by A cube divided by Z. So that is what we have written. Density is equal to Z into M divided by A cube multiplied by Na. Therefore, M is equal to D multiplied by A cube multiplied by Na divided by Z. Let us say this answer is equal to Y gram per mole. So this answer is equal to Y gram per mole, my dear students. So suppose the molecular weight is Y gram per mole. That means Y gram per mole or Y gram has a Na, that is 6.022 into 10 to the power 23. Remember, Y gram has got 6.022 into 10 to the power 23 atoms, and therefore, my dear students, we are given 288 gram. We are given 288 grams. So therefore 288 gram substance has how many atoms? And for that we can write it is 288. For answering this question, we write 288 multiplied by Na divided by Y. 288 multiplied by Na divided by Y. Now my dear students, 288 we have written Na and Y. What is the value of Y? We know that the value of Y is equal to what? D into A cube multiplied by Na divided by Z. So for Y we can write D multiplied by A cube multiplied by Na divided by Z. So we can easily say Na divided by Na is equal to 1. Now what is left with us is 288. Here we have 288 multiplied by Na get cancelled, then we have D A cube into Z. We know that the value of Z is equal to 2. We are already given the value of density, and we know the side so that we can take a cube of it. That means, my dear students, 288 multiplied by 2 divided by 7.2, that is 7.2, that is the side or that is the density. What is the density? 7.2 gram per centimeter cube. So we have taken 7.2 gram per centimeter cube. And for the side, my dear students, we will take the value of centimeter because the density is given in centimeter. So we will write 288 cube multiplied by 10 to the power minus 10 cube, that is 10 to the power minus 30 cube. Now, my dear students, doing the required calculation, this 10 to the power minus 30 when it goes into the numerator turns out to be positive, and then by doing all this calculation, my dear students, we find out the answer as 2.4187 multiplied by 10 to the power 24 atoms. So please remember by doing all these calculations. So these kind of questions are very easy to solve if you have a proper ability to do proper mathematical calculation, that is multiplication and subtractions. Let's go and understand the next question. Do you have any doubt in this? कुछ पूछना है बच्चों?
No, sir.
No.
Okay, good.
No, sir.
Thank you for your enthusiastic reply. Please pay attention and understand. We have the next question. X-ray diffraction studies show that copper crystallizes in FCC unit cell with edge of 3.60 into 10 to the power minus 8. So this is what it is the value for your A. In separate experiment, in another experiment, copper is determined to have density. Density D is given, my dear students. Now you need to calculate the atomic mass of the copper. So M is a question mark. We know that, my dear students, this kind of questions are very simple to be solved. We are given here FCC, that means Z is equal to 4. We need to calculate the value of M. We have the formula D is equal to Z into M divided by A cube by Na. And we are already given the value of A. We know the value of Na. Therefore, from this formula, we can write M is equal to D into A cube multiplied by Na divided by Z. The density that we are given is 8.92, my dear students. So we can write this value, then 3.608 into 10 to the power minus 8 cube. This is the value for our A. Density is 8.92 gram per centimeter cube is given, my dear students. We put the value of Na here, and then we divide it by Z because Z is equal to 4. We write it 4, and by doing these all calculations, we can say that the molecular mass is 63.1 gram per mole. Now we have the next question. Silver forms CCP lattice. CCP means FCC, my dear students, phase center cubic cell. And X-ray studies of its crystal show that the edge length of its unit cell is equal to this picometer. So this is what you have A. Calculate the density of the silver, molecular weight, or here as silver is atom, so atomic weight is given, that is 107.9. We know that the formula density is equal to Z multiplied by M divided by A cube into Na. For Z we can write 7, for M we can write 107.9, for A we can write 408.6 into 10 to the power minus 10 centimeter, because density can be measured into gram per centimeter cube, and then we have the value of Na. By doing all this calculation, my dear students, we can find out that the density of that silver crystal is 10.5 gram per centimeter cube. Then we have the next question. What is dimension coordination number? We need to find out the dimensional coordination number of molecule in square closed packed structure. So let us understand, my dear students, though we have understood it, this square closed packed structure is possible only into 2 dimensions. So it is even clearly asked that of molecule in 2 dimensional, it is clearly asked that in 2 dimension, what is the coordination number? You can see when we arrange the atoms into the 2 dimension, each particle is in the direct contact with the 4 other particles, and that is why we can say that the coordination number is 4. Then we have the next question, my dear students. A compound forms hexagonal closed packed structure. What is the total number of voids in 0.5 moles of it? Please remember that here the total number of voids we need to find out, that is present into 0.5 moles of it. How many of these are tetrahedral voids? So let us answer these questions. It is going to be very interesting for us to solve this question, my dear students. Let's have a look to the answer of this question. Now, please pay attention. In hexagonal close packing, in one unit cell, we have 6 atoms. We are very well aware that we have calculated that in hexagonal close packing, in HCP, one unit cell has got 6 atoms. So your Z is equal to 6. And thus we have 6 octahedral voids because number of your n is equal to 6. So your tetrahedral void will be 2n, that is 12, and your octahedral void would be equal to n, that is 6. So in each hexagonal cubic cell packing, we can say that we have 12 tetrahedral voids and 6 octahedral voids, and thus we have 6 octahedral voids and 12 tetrahedral voids. Now 1 mole has 6.02 into 10 to the power 23 atoms. Therefore 0.5 mole will have 3.011 into 10 to the power 23. That is this number divided by 2. So this much of atoms are available. Now total voids that we have is equal to 18 voids, 12 plus 6 per 6 atoms. We have total voids 18 voids per 6 atom. Please remember, my dear students, in hexagonal close packing, we have 6 octahedral voids and 12 tetrahedral voids. We have arranged the 6 atoms. So per 6 atom, we have 12 plus 6, that is 18 voids. Now you can see that for 0.5 mole, we have this much of atoms present. Therefore, 6 atoms has 6 atoms has 18 voids. Therefore, this much of atoms will have how many voids? That means 3.011 to the 10 to the power 23, 10 to the power 23 voids divided by 6 multiplied by 18. That simply gives us the answer. So, my dear students, the total number of voids would be, 9.033 into 10 to the power 23. This is the total number of voids, which is multiplied by 3. Because if suppose this is your number y, so y divided by 6 multiplied by 18. So 6 3s are 18 and y is equal to this. So this multiplied by 3, that gives us the 3.011 multiplied by 3. So 3 1s are 3, 3 1s are 3, 3 0s are 0 and 3 3s are 9. This will be the total number of voids that we will have. Now we want to find out the total number of octahedral void and total number of tetrahedral voids. So we know that if we have 3 atoms, or then one would be the, so 2 into 3.0001 into 10 to the power 23, this much of tetrahedral voids, and 1 into 3.002, that is the octahedral voids that we have. So my dear students, we will have total 6.022 into 10 to the power 23 tetrahedral voids, whereas we will have 3.011 multiplied by 10 to the power 23 octahedral voids. Now you may have this question that how do we get this? So please remember that for 6 octahedral voids, my dear students, we will have 12 tetrahedral voids, and 6 octahedral voids are present per 6 atoms. So, my dear students, the total number of particles that we have arranged, they are 3.011 into 10 to the power 23. So, total number of octahedral voids would be the same, and the total number of tetrahedral voids will be double of this. So that is why when we put it double, we will get the octahedral voids, and if we write the same number, we will have the total number of octahedral voids. If we put it double, we will have the tetrahedral voids, and if we have the same number of particles, we will have the octahedral voids. And if we make the sum of these two, that is 6.022 into 10 to the power 23 and 3.011 into 10 to the power 23, we will get the total number of voids, that is 9.033 into 10 to the power 23. बच्चों अगर इसमें कुछ समझ में नहीं आया तो पूछ लीजिए,
आ गया,
देख लीजिए बच्चों, if you have any question, or we can move forward. Dear students, किसी को भी कोई प्रॉब्लम है तो प्लीज पूछ लीजिए.
No, sir.
All of you please, सब लोग रिप्लाई कीजिए. एटलीस्ट समझ में आ गया है तो बता दीजिए बच्चों.
समझ में आ गया,
समझ में आ गया,
समझ में आ गया.
Very nice, very nice. Thank you. So now let's move forward and understand the next question. A compound is formed by two elements M and N. The element N forms CCP and atom M occupies 1/3 of the tetrahedral bonds. What is the formula of a compound? So let us move forward. That we have the two elements M and N. Now Y atoms of N are arranged. Suppose we have Y atoms of N are arranged because it forms the CCP. We are very well aware that if we arrange N atoms, then we will have N octahedral void and we'll have 2N tetrahedral voids. So if we arrange Y atoms, we will have Y octahedral voids and 2Y tetrahedral voids. Now what does the question says? M and N, the element N forms CCP, that means the arrangement of the particles, and M occupy 1/3 of the tetrahedral voids. So your M is occupying 1/3 of the tetrahedral voids. That means 1/3 multiplied by 2Y. So these are the total number of particles present of M, whereas Y particles of N are present. So my dear students, if Y atoms of N are arranged, total number of tetrahedral voids would be 2Y, or they have written X. So let us write X. So if X atoms are arranged, then the total number of voids would be 2X, and 1/3 of the tetrahedral void would be 2/3Y, so 2/3X. So that is what it is, the total number of the tetrahedral voids. Now let us put M is to N is equal to, what is the number of M, my dear students? Number of M is equal to 2X/3. Number of N is equal to X. Now if we multiply both this ratio with 3, so 3 multiplied by 2X/3 is to 3 multiplied by X, that gives us 3X. When we cancel this 3, we will get 2X is to 3X. So my dear students, we can say that M is to N is equal to 2 is to 3. That means the formula is going to be M2N3. So as this M is to N is equal to 2 is to 3, thus the formula is M2N3. It simply means that when you have 2 atoms of N, you have 3 atoms of N. Once again, when you have 2 atoms of M, you have 3 atoms of N. That means the formula is M2N3. It is very easy to understand, but still any of you have any doubt, you can ask me. बच्चों आप में से किसी को भी अगर कोई डाउट है तो प्लीज पूछिए.
समझ में.
देखिए, अगर आप जागृत हैं, आप पार्टिसिपेट कर रहे हैं, तो तुरंत ही ऑन करके नो बोल दीजिए. आपको भी मजा आएगा और मुझे भी अच्छा लगेगा. ऑल ऑफ यू प्लीज. चलिए, लेट्स मूव टू द नेक्स्ट क्वेश्चन माय डियर स्टूडेंट्स. Which of the following lattice has the highest packing efficiency? Now this is what it is, the knowledge based question. Simple cubic, body centered, or hexagonal close packing. So can you tell me what is the packing efficiency of simple cubic? Approximately 52%. This is approximately 68%. And this is what it is going to be, 74%, and that is why this is highest. Let's move to the next question. An element with molar mass of but molar mass is given in kg per mole, forms a cubic unit cell with the edge length A is given. This is what it is, M is given, A is given. If its density is also given, you can see this is density. What is the nature of the cubic unit cell? That means how can you find out nature? Nature you can find out by using the Z. If your Z is equal to 1, it is primitive. If it is 2, then it is body centered. If it is 4, then it is face centered cubic cell. So my dear students, these are the various values which are given. First, let us consider the molecular weight, which is 2.7 into 10 to the power 2 kg per mole, and let us convert it into the gram per mole. So how can we convert kg into gram? By multiplying it with the 1000, we can get the gram. So it is 27 gram per mole. That is how we can easily understand. Then my dear students, the edge length is given 405 picometer. As the density is given kg cube. let us write out, here we have got the molecular weight gram per mole. So let us convert it into gram into centimeter. So 405 into 10 to the power minus 10 centimeter cube. Density is given 2.7 into 10 to the power 3 kg per meter cube, which when we convert it into the gram per centimeter cube, it remains the same 2.7 gram per centimeter cube. Now please remember, my dear students, that density, either it is represented in gram per centimeter cube or it is represented in kg per centimeter cube, both are same. So here we have the density is equal to 2.7 gram per centimeter cube. Now we know that the formula D, density is equal to Z into M divided by A cube into Na, and therefore Z is equal to D into A cube into Na divided by molecular weight. So let us put all these values, my dear students. For density we write 2.7 into 10 to the power 3. For A we write 405 cube multiplied by, or let me write it 405 cube multiplied by 6.022 into 10 to the power 23. This 405 cube into 10 to the power 30, we can write it over here, 10 to the power minus 30. Yes. So you can see that, my dear students, I have written 10 to the power minus 30. This is 227, 10 to the power 405, and by doing all this calculation, my dear students, the answer what we get is approximately 3.999, which is equal to 4, and we can say that the type of unit cell what we have is FCC face centered unit cell. Another method of calculation is tracking efficiency for HCP, my dear students, but we will not go in deep about this another method of calculating the HCP. What I have today explained you, this method is already given into your notes, so we are not going deep into this calculation. This information, my dear students, I have shared with you just in the beginning of the class discussion today. But please remember, for simple cubic, R is equal to 1 by 2a. For body centered, R is equal to root 3 by 4a. For face centered cubic cell, R is equal to 1 upon 2 root 2a. For hexagonal close packing, R is equal to root 3 by 4 square root a. For H is equal to root 3 by root 3 for R. And for area of hexagonal, 6 multiplied by root 3 r square. So these are the values which may be useful, and you can use them here and there. Then, my dear students, today we can move and understand about the imperfections in solid. But we do not have enough time, so in the next period we will revise these imperfections in solids. My dear students, if you take notes or if you pay attention, you will realize that we have been solving almost very important and almost all kind of questions that are given into your exercises. So you can even start writing the exercises, as well as you can I shall send you soon the CBSE exemplar also, so you can solve that. Now if you have any question, you can ask me. If you have any doubt, you can ask me, dear students. बच्चों, अगर आपको कोई डाउट है तो आप पूछ सकते हैं. Anyone